Today we're going to show you how to create a bitmap image using just the hex code or hex data that goes inside of it. So first thing we would need to know is what the width and the height of your image is going to be, and then you take that and convert it into hex. So for this one we're going to have 14 pixels wide by 16 pixels height. So then next to that you can see is the hex code for that. Next thing we would need to know is the row size. So in this we have 3 pixels, or for every pixel we have 3 bytes corresponding to red, green, and blue. So if you take that by your image width, it gives you 42 bytes per row. Now technically in Bitmap the way it works is they always round it to the next highest multiple of 4 because it likes to take 4 bytes at a time. So they use this equation here where you have your 3 bytes per pixel. You convert that into your number of bits per pixel. You multiply it by your image width plus 31. Take all of that, divide that by 32, and multiply it by 4. And that gives you, we're going to have about 44 bytes for every row. So then after that, so that means between the 44 bytes and our 42 bytes, we end up with 2 extra bytes there that are just going to be padding. It means they don't do anything, but it helps the bitmap image with actual processing by the computer. So then to find out how large our file is actually going to be, you take your total row size, including the padding, multiply that by your 16 pixels high, or whatever your height is. That'll tell you the number of bytes that are in your file for the actual image data. Now, alongside the image data, there's also header data. This header data is your bitmap file header, which says a little bit of information about the size of the file and telling your system that it's actually a bitmap image. And then there's also the Dib Header, which this is including information about how wide your pixels are, how many rows you have, what colors you're using, what your resolution is. There's a bunch of information on what is actually going on in the file in this. And so once you have all this information figured out, then you can actually start going into creating your bitmap image. So, okay, what I'm going to do is just go ahead and shift this over and then leave it here visible because we'll need some of this information to be put into the header. The program I'm using is called 0xed found. It's kind of a pretty nice one to use on the Mac. So I'm just going to go ahead and save this blank file to my desktop just for easy access. And then we'll get to creating your file. Now in the bitmap file, the first 2 bits always have to be the same. It's BM for a Windows bitmap. So your first 2 bytes are 42 and 4D. That's the way it's always been, and that's what it's going to have to be if you're using a Windows bitmap structure. The other operating systems, they do it a little bit different, but in most part it's always a BM. The next 2 are always going to be the size of your file, or the next 4 bytes actually are the size of your file in bytes. And so for ours, like I said, the total file size is 758 bytes, which ends up being 246 or 2F6. So and then you pad out the rest of it with zeros. The next 2 bytes are application dependent, and same with the 2 after that. So that's why we have the 4 zeros right there. And then now the last part of your bitmap header, last 4 bytes of that is the starting address of where your actual image data is going to be. So that whole structure right there, that is your standard bitmap header. The next part of this is your Dib Header, which we're going to use the Windows bitmap info header as our template here. So the first 4 bytes of this is going to be the size of the header itself, which that in this case is always going to be 40 bytes, so it ends up being 28 in hex, and of course we have to pad out the other 3 bytes with zeros. next part of this is your actual image width. So you can see over here it's 0xe. So we just need 0e for the first byte, and then we put the rest of the 3 bytes because it's another 4-byte system with zeros. And then same thing with the height. It's 4 bytes. So we come over and look at our height, which is 10, and we pad out the rest of it with 3 zeros. Now for this, we're only going to do 1 row at a time right now, so I'm going to go ahead and change this height to be 0, 1. So that way we can work at 1 byte at a time, 1 row at a time, and we can see the change without it generating an error for us. So each time we add a new row, we'll go in and change this number up at 1 more, and we'll be good to go. After that is the number of color panes that are used, which this must always be 1, and it's 2 bytes there, so we have 1, 0, 0. After that is the color depth. 18 gives us a color depth of 24, which is what you get with RGB, because you have the 3 values, the 3 bytes, which is 3 times 8 is 24, and that's a 2 bytes, so we pad that out. After this is the compression setting to be used. We're not using any compression, and it's a 4-byte system, so we have to put in our 4 bytes there and pad that out. After this, it's the image size. This is now your actual image data, not the entire file size, but just the image data. So we look down here, we had 704 bytes, ended up being 2C0. This had me put it in a weird way, just so that way, as you can see, it would come out at the bottom correctly as 2C0 in the right size. The next part of here is your horizontal resolution, which you can put it in here if you want to specify a resolution different than your standard, but we're not messing with that, so we're just going to use whatever standard is. And same with the next one, which is a vertical resolution, so that gives you 8 bytes total between the 2 of those. So we just pad those out. Then the last 2 bits of information in here are your number of colors in your palette. You can default that to 0 because we don't have to worry about it. So we put 4 bytes in there for 0, and then the number of important colors we're using were 0 is every color important, so we just left it all at 0. So you can see we ended up at an offset of 36, whereas in the bitmap info header we told it was 36 also. So that means we are right where we should be. We have the information we need in there, and we are set up to actually start doing our image data now. And now you can see here, from here to here, this whole section here that's highlighted, that is your Dib header. That is the information about your colors, how big your photo is, how wide it is, and other information along that lines. And this is dependent, it can vary depending on what type of header you want to use. So now let's actually start looking into adding our image data. And so the image that I'm using, like I said, is it's 14 pixels wide, and then the first 3 pixels on this is going to be white. And now for bitmaps, they always start at the bottom and they work their way up. Unlike what you normally think where you start in the top left corner, you're starting in the bottom left corner. So now I go across and I had my 3 white pixels. As you can see, it was FF, FF, FF. And then for 1 pixel, it was the 3 of the Fs. So that's why we have 9 of them there, because there was 3 pixels. And then I ran into my first color that I have on there. And so for bitmap images, typically most images go, when you're working in hex or any type of color system, it's red, green, blue. Bitmaps do it opposite. It becomes blue, green, red. So you have to make sure you get your values in the correct order, otherwise your colors sort of come out almost inverted. So we ran into the first color here, and so that was 1045 D8. I have 3 of those that are 3 pixels that are that same color in a row. So I'll go ahead and put all 3 of those in, and then after that I've got 2 more white pixels that go in there. So we'll do 3 Fs again, 3 sets of FF for 1 pixel, and we'll do another set of 3 FFs for the next white pixel. And then once again, we run into the same 1045 D8, and we'll do that 3 times again, because it's kind of a mirror image at this point here. So, and then the last 3 pixels are going to be white, so you'll see another 9 FFs here. And this is where we run into our first case for padding. So from here to here, we have 2A, which ends up to be our 42 bytes already. Now, we said that in bitmaps there's like padding if it doesn't work out to be an even number of bytes that can be divisible by 4. So we have to add in our 2 padding bytes, and that's simply we just put in 0, 0, 0, 0 for our 2 bytes. They don't do anything in tech. You can really put in whatever value you want for them, but we just have to have those 2 bytes as padding. Otherwise, our next row will be colors we messed up as it starts reading from the wrong area. So then I'll go on. So you can see as I saved it, now we actually have our first little image here. So I'll go ahead and pull it up. And of course, it's really, really small because of our screen resolutions now. But you can see I've got basically three white pixels, 3 colored pixels, 2 white pixels, 3 colored pixels, 2 white, and 3 white pixels there. And so here I'm going to pull up a little bit more of the file information so you can just kind of see and get things a little organized on the screen here. So as you can see, it's a Windows bitmap image because we told it it's going to be a Windows bitmap image based on our file headers. So, and we're at 98 bytes. So if you went through and counted each of those, you'd be pretty close to that. And then we said it's going to be 14 pixels wide by 1 pixel tall. And that's what we end up having here, 14 by 1. And the DPI, that's kind of your horizontal vertical resolution, which we set to just default whatever it saw as best. And you can see color depth is 8. So now that we have that, let's go ahead and start adding in our second row. So I'll go ahead and change this to a 0, 2, and that means we can add in the second row now, and we won't have any errors while we try to view the file. And my second row ends up being exactly the same as this first row, so I'm just going to take this, copy it, and paste it down below, and save me some typing. So now once I save that, you'll see on the right here that things actually update, and now we have the same thing. It's just now it's 2 pixels high instead of the 1 pixel high. And of course our bytes increased by the 44 bytes that we needed. And we just added in. So now you continue doing this the same way through. You add in your next row, you change the number for your rows up there, and then you can view your file. And so I'll just go ahead and add in the third row here, which is somewhat similar. It's got 2 whites, and then now we're using a different color. So that's why you get the 16 FCAD, but that color is now going to go quite a few pixels across. So I'm just going to go ahead and copy this and save some typing and just paste it for the number of times that I need to use it. And I'll close off my row with the white pixels that are around it, and then add my padding. So now that I've added a third row, I need to go up here, change this to 3, so it knows to actually generate that third, and there you go. There's the third row. And so like I said, you just kind of follow the same process to adding into each one. It makes it a lot easier if you go row by row, because then you can test it each time and you can find out whether it's working or not. So, whereas if you just go ahead and tell it that we're going to do all the data at one time, you set your rows up, I went ahead and changed this to 10 and tried to save it, it's going to end up causing an error. So save error there, and now you cannot view your file until you have enough image data in there to actually populate all those rows. So I'm going to go ahead and go through this and go ahead and get that image populated. And once that's done, we'll come back and then I'll open up the final file here. And so now you can see I've got it all populated here. I've saved the file, and so now I'm going to open it up. And as you can see, it's still 14 pixels. It's pretty small, 16 pixels high. It's not that much better. So once you zoom in, now you can see your finished image there. And we have 758 byte file size. You can see that's what we calculated. Our pixel, our width and height are right, and we've matched out everything else. So as you can see, here's all the data that went into actually creating this bitmap image. So you have your header and then telling about what the file is, how to read this file, and all that information. And as you can see, there is a lot of image data. So you have 3 bytes for every single pixel that you end up using. But as you can see, it is quite possible to just generate an image without ever opening a graphics program, just by using binary information. In our case, we were just using hex instead of doing straight binary. But it is possible.